you in the program. Then in the later half of the program, Nazir Ahmed Tantre sir, a renowned name in the world of physics, and as when we talk about teaching physics to the students who are preparing for the various competitive examination, here is a name who is absolutely invincible and insurmountable in this regard. Very few teachers in the subcontinent can match him as when it comes to teaching those physics numericals. Because I'm telling you this because I have been his student in the year 2003. So a very warm welcome to you in this very program. And dear friends, we'll meet you and the lecture will start. But before that, a short break. एक बार फिर से हमारे साथ बने रहने के लिए आपका बहुत बहुत शुक्रिया ख़वातीन व हज़रात। और चलिए आज का लेक्चर स्टार्ट करते हैं, लेकिन उससे पहले ये भी बता दें कि इस प्रोग्राम का रिपीट टेलीकास्ट आप देख सकते हैं एवरी ट्यूसडे इवनिंग फ्रॉम 7:30 to 8:30 एंड देन एवरी थर्सडे मॉर्निंग फ्रॉम 9:10 to 10:10। और ये भी बताते चले कि यह प्रोग्राम आप तक डीडी दूरदर्शन केंद्र श्रीनगर और डायरेक्टोरेट ऑफ स्कूल एजुकेशन के बाहमी इश्तराक से पहुंचाया जाता है। तो चलिए आज का लेक्चर स्टार्ट करते हैं। खुर्शीद अहमद रहते, द स्टेज इज ऑल योर्स।
Assalamu alaikum Nazreen.
Walaikum assalam.
Today's topic we have chosen as the light. I feel first of all pleasure that I am sharing the dice one of the leading legend in the physics, that is Nazir Ahmed Tantre sir. Light, as you know, is defined as the electromagnetic wave. Besides this visible light, in the electromagnetic wave we are having gamma rays, we are having X-rays, we are having ultraviolet rays, we are having IR rays, and we are having microwaves, and at the last these radio waves. So far number of theories have been put forth in the aspect of the light. First theory came from the desk of the Descartes and Newton. This theory, which was put forth by Descartes, it was later on modified by the Newton, and it is called Newton's corpuscular theory. According to this theory, light consists of the tiny corpuscles of the light, and they explained the reflection and the refraction on the basis of this, that whenever these tiny corpuscles are being repelled by a substance, then the reflection takes place, and whenever these tiny corpuscles of the light are being attracted by a substance, then the refraction takes place. But this theory is conflicting in its own design from the prospect of this very thing, because it contradicts its own design, because the main thing is that you can see through this as well as you can see this, means reflection as well as refraction takes place on a transparent material. So it is not possible that a substance can repel as well as attract the thing simultaneously. So then there was the need of the new theory which was put forth by the hygiene and later on modified by the Fresnel, and this is called the Hygienist wave theory. According to this theory, light is a periodic disturbance transmitted through a material medium in the form of the waves. But he also inculcated there the ether concept. That ether concept later on was removed there by the Fresnel, and he also put forth there that this C is equal to velocity of light is equal to E divided by this rho, means that the velocity the elasticity of the ether is very large, but it is impossible that whenever a material medium is we are having elasticity very high but the density very low. This theory did not survive, but however it explained a number of the things, and the main role in this was played by this Thomas Young, who gave us that double slit experiment. Then this theory also explained what we call as this interference, diffraction, and reflection, but it did not explain the rectilinear propagation of the light. Simultaneously, the need of the time was, and the demand of the time was to go for some more theory, and that came from the desk of the Maxwell, which gave the electromagnetic theory of the light. And that electromagnetic theory states that this light is an electromagnetic wave, where light electric field vector and the magnetic field vector are perpendicular to each other, and both of them are perpendicular to the direction of the propagation. And lastly, then one more theory came from the Einstein, which is called Einstein's quantum theory, and he put forth over there that the light consists of the streams of the photons, and those streams of the photons, they are also called the packets of the energy, that explain the photoelectric emission, and that explain the Compton effect, emission and absorption of the radiations. But these theories, none of the among the four theories were in a position to explain the whole phenomena involving in the light. They are written in the beneath of the table, that are reflection of the light, refraction of the light, TIR, you are having dispersion of the light, you are having interference, you are having diffraction, you are having polarization, you are having scattering of the light, you are having then this photoelectric effect, Compton effect, absorption, emission of the. Then lastly, the theory was put forth by the de Broglie, who stated that light is having dual nature. It behaves as a wave as well as it is having a particle nature. Now these number of phenomena so far which have built the whole optics, they start from the reflection. Our program today is actually we used to show you here the low cost, no cost programs on the basis of this. I will first of all try to explain for you people the reflection that is in your class, in the elementary class, right, started from the 9th class. So in the reflection, what do you understand by what is the reflection? Yes? Reflection, not refraction.
So reflection means the bending of light when it passes from one medium to another medium.
That is refraction. I am telling of the reflection.
The sending back of light.
It is bouncing back of light. It is bouncing back of light. And in this reflection, you are having there are two laws. That is, first law is, you may have read that the incident ray, reflected ray, and the normal lie in the same plane. I am having a simple design for you people today to show those all what we call as rays, incident ray, reflected ray, and the normal, how they lie in the same plane, isn't it so? And how that angle of incidence is equal to angle of reflection. Let us find. I will first of all try my best to put some what we call as this scattering agent into it, and I am having here this is joystick, or you can say in synthetic. I am putting some of these smoke into it so that the scattering of the light may take place inside when we put the beam of light in it, and then you can see the path of that light, isn't it so?
Yeah.
Because in the absence of the smoke you cannot be in a position to see the path. Okay?
Yes, sir.
Please help me, sir. You see now. नजर आ रही है आपको इंसिडेंट रे?
Yes.
रिफ्लेक्टेड आ रही नजर? नजर आ रही है? ठीक है, तो क्या है पहला जो लॉ है आपका वहां पर रिफ्लेक्शन में, इंसिडेंट रे, रिफ्लेक्टेड रे एंड द नॉर्मल lie in the same plane. See how they are lying in the same plane. It is often confusing to students what this plane is. If this is x-axis, this is y-axis, this is z-axis, means this plane is xy plane. xy. Here you can see that incident ray is in the xy plane, reflected ray is in the and normal. I have put a protector over here which can measure the angle later on. So we can draw normal like this. This acts as a normal. This acts as a normal. Means that all these rays are lying in the same
Plane.
Is it explained to this?
Yes, sir.
Now, second law. What is second law? Angle of incidence is always equal to angle of reflection. See, if I am putting here the ray of light over here and I am increasing the angle. I am increasing the angle. Is it are you in a position to see the both the rays? I am increasing here the angle. And the angle of incidence I am increasing. Angle of reflection also increases. Angle of reflection also increases. But this laws of reflection are obeyed by whether it is a regular reflection, they are also obeyed. Whether it is irregular reflection, they are obeyed. And they are simultaneously obeyed by the curved surfaces also. That you are having those spherical mirrors where you are having the convex mirror and the concave mirror. See, you have to see this very thing. This is very important. इंसिडेंट रे आपको नजर आ रही है? रिफ्लेक्टेड नजर आ रही है? कहाँ जा रही है रिफ्लेक्टेड? रिफ्लेक्टेड कहाँ जा रही है? डाउनवर्ड जा रही है कि डाउनवर्ड जा रही है कि अपवर्ड? इंसिडेंट कहाँ जा रही है? इंसिडेंट स्ट्रेट है. ये देखिए आप, इंसिडेंट क्या है? लेकिन जो रिफ्लेक्टेड है वो कहाँ जा रही है? मीन्स जिस चीज पे ये लाइट पड़ी होगी, व्हाट सॉर्ट ऑफ अ मिरर विल बी देयर? कौन सा मिरर वहां पर होगा? यस, मिरर्स आर ऑफ two types. Spherical mirrors are two types. कौन से हैं? Concave and convex. Concave means which is converging, which converges the light, and convex means so यहाँ क्या हो रहा है? यहाँ क्या हो रहा है? Converge हो रही है कि diverge हो रही है? क्या हो रही है? Diverge हो रही है. तो यहाँ पे कौन सा मिरर होगा? शाबाश. ये आप देखिए अगर मैं यहाँ पर इसके पोल पे लाइट डालता हूँ तो you are not in a position to see the two rays. There is only one ray. तो क्या होता है उस वक्त? उसका मतलब ये है कि जो इंसिडेंट रे है वो उस वक्त पोल पे पड़ती है. रे भी कहाँ से? पोल और सेंटर ऑफ कर्वेचर से बाहर जाती है. ठीक है. तो जो ये मिरर था, कौन सा मिरर था? अब ये मीन्स दीज लॉज ऑफ रिफ्लेक्शन आर ओबेड ओवर हियर आल्सो. ठीक है. इसके बाद जरा और अब गौर करें इस पे. ये देखिए कहां जा रही है इस वक्त? कहां जा रही है? नजर आ रहा है? नजर आ रहा है? थोड़ी लाइट की वजह से आपकी थोड़ी डिफिकल्टी वहां होती है. ठीक है. अपवर्ड जा रही है. मीन्स व्हाट सॉर्ट ऑफ मिरर विल बी देयर? Which mirror? Concave mirror it is. ठीक है.
यहाँ में थोड़ा सा
हाँ
add certain things here.
Please.
The reflection of light from any surface.
Yes, sir.
Whether it's a mirror or it's a concave surface, जैसे सर ने कहा है. These reflection rules, maybe the reflection is from mirror, it is from any curved surface. The reflection was explained by Newton's corpuscular theory.
That was explained.
And this reflection rule is also explained by Huygens wave theory. And this reflection rule is also explained by Fermat's principle of least time. So when light goes from one point to another point, it will follow the path of least time. It will follow the path of least time. So it is something like that. There's a mirror and light falls on the mirror, it goes to the other place from A to B. It will follow a path of least time. When we follow that mathematically, it becomes that angle of incidence is called angle of reflection. So the reflection rules are being explained by all the three theories, Newton's corpuscular theory and Huygens wave theory, and the best principle, what is called as Fermat's principle of least time. The Fermat's principle of least time states when light goes from one point to another point, maybe in the same medium, maybe in different media, from one medium to another medium, it will follow the path of least time, or it will follow the path of stationary time. You understand my point? Yes, stationary time means if you change the path by a little amount, the time variation is negligible, or it is what you call as invariant to the first order of variation. It is mathematically put like that.
जी बिल्कुल. So thanks a lot for that timely intervention. Please continue, sir.
हाँ, ये आपको समझ आ गया? और नाज़रीन से मेरी इल्तिजा ये चीज़ है, स्पेशली फॉर द टीचर्स, दैट इट इज़ नॉट डिफिकल्ट टू डिज़ाइन सच ए लो कास्ट नो कास्ट एक्टिविटी. बेसिकली जब भी हमारा ये प्रोग्राम होता है तो हमारा यही थ्रस्ट होता है कि जो टीचर लोग ये देख रहे होंगे ताकि वो भी ऐसे ही डिज़ाइन तैयार करें. तो इस तरीके से आसान होता है बच्चे को समझाना कि किस तरीके से प्लेन कौन सा है, इंसिडेंट रे कहाँ पर है, रिफ्लेक्टेड रे कहाँ पर है. इज़न्ट इट सो? सो नाउ you are having simultaneously in their syllabus that image formation by the mirrors. First of all, I will aware you to the rules for that. You are having the 4 rules for the image formation. Rule first is whenever the ray of light passes through the center of curvature, that retraces its path. Rule first. Rule second is if the incident ray goes parallel, and then it is converged towards the focus, isn't it, or appears to converge in case of the concave mirror, convex mirror. Then rule third is if the incident ray passes through the focus, then the reflected ray is parallel to the principal axis. And the rule 4 is if the incident ray falls on the pole, then it is reflected according to the law of the reflection, that angle I is equal to angle R. So you are having number of those images in case of the concave mirror and in case of the convex mirror. And I am having a simple trick and a design that you can make yourself that very thing also. Otherwise you have to remember so many things over here, isn't it so? So this is for the the image formation in case of the concave mirror. गौर से देखिएगा. This is the incident ray. This is the incident ray. तो इसको कहाँ से जाना होगा? Focus से. गई या focus से? This acts as a secondary axis. This acts as a secondary. See, now if the object is beyond the center of curvature, you have to determine where the image is formed, because when you define the image formation, you are saying that there are the two types of the images. One is the real image, another is the virtual image. Real image is that image where the incident and the reflected ray can meet, isn't it so? Where they actually meet. See, you can see if the object is beyond the center of curvature, then this is the reflected ray, this is the reflected, okay? The image is formed, between focus and जहां पे उन्होंने intersect किया, समझ आ रहा है? ठीक है? If the object is at center of curvature, यहाँ पे center of curvature पे, ठीक है? Image is formed at, इसमें एक खुसूसियत है इस इमेज में, क्या है? Of the same size, क्या है? Same size. जितना ऑब्जेक्ट की लेंथ होगी, जितनी ऑब्जेक्ट की लेंथ होगी या साइज होगा, उतनी किसकी भी होगी? शाबाश, इमेज की भी होगी, ठीक है? If the object is, now you can see I am rotating this like a clock because I have named it image clock. Image. If the object is between center of curvature and focus, then the image is formed. Image is formed beyond the center of curvature. Beyond the center of curvature. And in all these cases, the images are real images and inverted images. But in the first case, image was smaller. In the second case, image was of the same size. And in the third case, image is of larger size. Image is of larger size. If the object is at focus, then the image is formed at good, nice, because these two rays does not appear to meet, then the image is formed at infinity. If the object is between focus and pole, then the virtual image is formed. Virtual images, that is behind the mirror. That is behind the mirror. आसान है याद रखना, difficult मत है, ठीक है? So this was in case of concave mirror. This was in case of concave. Now in case of the convex. In case of convex mirror, you are having this the inner side is polished. Yes, sir. Inner side is polished. Isn't it so? Yes, sir. You are having only two types of the images in case of the convex mirror. That is if the object is at the infinity and if the object is between infinity and the pole. But I have placed so many things because in order to show you people the size of the image. As you are coming close to the mirror, the size of the image increases. If first of all, if the object is at infinity, the image is formed at focus. The image is formed at focus. Number one, yes, because here these two rays appear to meet. If the object is at focus, then again between focus and pole. But this image is larger than that, which was, isn't it so? Yes, sir. As I am coming closer to the mirror, the size of the image increases. But these all images are virtual images. Virtual images. Isn't it so? Yes. Means you have concluded that when you are coming towards this convex mirror, the size of the image increases. But all the images are virtual images. ठीक है?
Here I need to add a little bit. In case of any mirror, maybe it is concave, maybe it is convex, maybe it is plane mirror. And an object, and you need to form the image of an object. That is all you need. You have an object, you have a mirror of any sort, right? And now you want to form an image. What is my recommendation? You start two rays from the object. Yes, sir. Just two rays. And see after refraction where they converge. That will give you the image. Yes. That will give you the image. I want to show you two examples. What is the crux of the image formation. So it must be as simple as possible, right? Yes. Okay, let me show you two examples.
Yes, sir, please.
Which mirror you want to take? Convex. Convex or concave?
Concave.
Okay, whichever. It's a concave mirror, right?
Yes, sir.
It's the principal axis.
Yes, sir.
Wherever you want to put your object.
Sir.
No hard and fast rules.
At focus.
That will be simple. If you put it at focus, that will be simple.
What's the center of curvature?
Center of curvature, that will be also simple because the image will be formed there.
Beyond the center of curvature.
Just a minute. Place object anywhere you like. If you want to place object at the focal point, okay. If you want to place the object at the center of curvature, okay, I will do that. But it is a general point. Those are anyway two special points.
Sir.
The general way of doing things is better than to doing a special case of the things, because general is applied everywhere.
Yes, sir.
Tick. Now I want to produce image only by 2 rays applied. That will be simple. You can produce image by any multiple rays applied, maybe 3, 4, but that will be a little complex. So what I do is, I will start 1 ray of light here. It will be reflected like this. It will be following what rule? Reflection rule, because angle of incidence is called angle. So if you draw a perpendicular here, this angle should be equal to this angle, right?
Yes, sir.
Okay, this is 1 ray of light. It has been reflected like this. So what I have said, that you have to watch what happens to the reflected rays of light, where they meet. I want to put another ray of light. So the best way will be to put the another ray of light all along the principal axis. It will come back the same way, and it will meet here. The object image is here. Finished. So it is 1 ray of light. It is another ray of light. They meet here. Image is formed. So you may ask me that it is object is too small, or it's a point object. Suppose the object is extended object, something like this. Have a look. It's a mirror again, right? It is an object here, extended object. Again, I will make the image only by 2 rays of light. 1 ray of light, let me say it is parallel. It will pass through the focal point, right?
Yes, sir.
Another. You are very easy to trace that. Let another ray of light fall on the pole. It will be reflected like this. Image is formed here. Finish. This image point is produced here, and you extend the image here. So this is the image of this object. But obviously, when you see the image, it is inverted, but real, because here rays of light actually meet. So what you remember now? Any object, anywhere, start 2 rays of light.
Yes, sir.
See why they meet. Why they meet, their image is formed there. I can show you more examples. Suppose this is a lens here, right?
Yes.
It is an object here. 1 ray of light straight away, it passes through the focus, right?
Yes, sir.
Another ray of light through the pole, undeviated.
Yes, sir.
Here is the image. Finished. The image is real.
Yes, sir.
Why? Because the rays of light actually meet. You don't have to extend the rays of light to meet them on the principal axis.
So wonderful intervention.
So
yeah.
it is the image formed here, inverted image,
It's real.
but it is real. That's all.
Thanks a lot. Thanks a lot. Since we are bound by certain time constraints, so
Okay.
Thank you, sir.
thanks a lot, Ali.
What Tantre sir has explained you people, and that I also have designed for that very thing also, only for 2 rays. But this is in case of lens. In case of lens, you can see this is the incident ray.
Yes, sir.
This is the reflected ray.
Yes, sir.
Refracted ray. Remember this very thing. And this is that rotating clock.
Yes, sir.
Isn't it so? You can see now, if the object is beyond the 2f, beyond the 2, where the image is formed, between the f and 2f, just by 2 rays.
Yes, sir.
ठीक है? If the object is at 2f, then the image is formed at 2f. समझ आ रहा है आपको? जो आपको सर ने एक्सप्लेन किया इस तरीके से with the help of the rays. So you can have also this low cost no cost design for it.
Yes, sir.
ठीक है? So if the object is between the 2f and this f, then the image is formed at between 2f, beyond 2f. Isn't it so?
Yes, sir.
If the object is at the focus, you see, image is formed at
Infinity.
आ गए वो सब रूल.
Yes, sir.
ठीक है? Difficult मत है? So you can, what I have used for this is simply a cardboard material, and this is a plastic pipe, and then I have designed it. Just 1 ray I have to design. Simultaneously you can also have this for this concave lens. Isn't it so?
Yes, sir.
But in this case also the image is formed. Those are image formed, and these are virtual. Isn't it so? You can also have that design. ठीक है?
So I would like to know about dispersion of light.
Dispersion, I will touch that later on.
Okay.
Actually dispersion means the splitting of the light. Splitting of the light, but I will touch that in
Different
detail.
colors.
Now, we are having the refraction of the light. Refraction of the light. ठीक है? So what is refraction of light?
Which is the bending of light when it passes from one medium to another.
When it passes from one medium to another medium. I have placed here two mediums. One medium is this water. Second, here is some smoke, and if there is least smoke, I will add some smoke for the purpose of the scattering. Now let us find whether it will work or not. See, you can see. नजर आ रहा है कुछ? आपकी वहां नजर पड़ती है ना? इंसिडेंट रे नजर आ रही है? When that meets the interface, it bends. It bends. किस तरफ बेंड होती है? Towards the normal or away from the normal? Towards the normal. आप देखें? ठीक है? It bends towards the normal. Means that the incident ray in the upper portion, that is in the smoke. In the smoke. Smoke is rarer, and this is denser. When it meets at the interface, it bends towards the normal. It bends towards the normal. As a consequence of that, we can say, in other words, we say the refraction is actually change in the velocity of a light. Change in the velocity of the light. Now, you are having also the two laws for this refraction. You are having first light, incident ray, refracted ray, and the normal lie in the same plane. That is, again, you can say that if this is x-axis, this is y-axis, this is z-axis, then incident ray was in what plane?
XY.
In xy plane. Refracted ray was in xy plane. Normal is in
XY plane.
isn't it so? And then there is the second law. What is that? Ratio of sine of angle of incidence to the ratio of sine of angle of refraction is always constant, and that constant is called refractive index. That is called refractive index. And I am having a trick for refractive index for you people also. ठीक है? उसके लिए मैं आपको दिखाता हूँ what actually refractive index is. Refractive index किसे कहते हैं हम? शाबाश शाबाश शाबाश.
Angle of measure of the bending.
हैं? Refractive index. हाँ हाँ शाबाश. We say the refractive index is defined as the ratio of the velocity of light in the
One medium to another.
in the vacuum to the velocity of light in the medium. It is always greater than 1. It is always greater than 1. ठीक है? Sir, I need help.
Sir needs your help.
Please. आपको ये नजर आ रहा है जो मैंने इसमें रखा है? नजर आ रहा है? ठीक है, चलो देख लेते हैं इसको. देखो आप. So I am also having a broken test tube that I will put this broken test tube into the, it may be a puzzle for you people. I am putting this into the oil. किसमें मैंने डाला? ठीक है, ये आपको हैरान करने के लिए है. Then I will stir it. ठीक है, आप देखिए ये मैं बाहर निकालूंगा, ये वाला मैं निकालूंगा बाहर. ठीक है, मैंने अंदर कौन सा डाला था?
Broken.
ठीक है, तो मैं देखता हूँ कि वो कहीं जुड़ मत गया. जुड़ गया? क्या हुआ होगा? शाबाश. Can you explain this?
I guess it's already
हैं?
been given.
Actually आपको वो मैंने पहले ही इसमें रखा था,
हाँ, मैंने
वो आपको नजर नहीं आया.
No, I
Basically what is the thing? The refractive index of the oil and the refractive index of the glass is almost the same. इसलिए वो आपको नजर नहीं है. And both the refractive index of the glass and the oil is approximately 1.512, both of them. ठीक है, तो इसी refractive index actually determines the how much the light will be refracted. It gives also the optical density, but it is different from the mass density. उसके साथ इसको मिक्स ना करें. ठीक है, और एक चीज यहाँ पे आज आपने बताना है बेटा क्या है इसमें.
Broken glass.
कुछ पढ़ सकते हैं आप नीचे? नहीं.
No, sir.
ठीक है, आप जरा देखते हैं what sort of a change it will bring when I will put the oil in it. जरा पढ़ें आप. क्या है?
GSS Kulgam.
क्या है? आपकी हायर सेकेंडरी का नाम है, अभी नजर नहीं आया था। क्यों नहीं आया था नजर? अब क्यों नजर आ गया? Yes.
Density of oil.
If you show it to the cameras also,
Yes.
अगर आप दिखा दें,
हाँ,
जूम करने का एक थोड़ा सा 2-3 सेकंड का दे दें आप मौका, so that there आराम से
ठीक है।
से।
अभी नहीं आ रहा है। हाँ, अब आ गया।
हाँ, yes,
Yeah.
it's there. Wonderful. A big round of applause for this.
This is due to the fact, इसके ऊपर क्या लगी हुई थी? शीशे लगे हुए थे ना, broken pieces। आप नहीं देख सकते थे, because they were reflecting the light. Apart with reflected also. अब जब मैंने इसका एक ही मीडियम बना दिया, सबका रिफ्रैक्टिव इंडेक्स सेम है। जब सबका रिफ्रैक्टिव इंडेक्स सेम है, you are in a position to see the base. ठीक है?
Yes, sir.
So
Should I add?
after this, we are moving towards the this is the refractive index of the certain substances. Air is having 1, hydrogen is having 1 point,
Carbon dioxide.
00013. ठीक है? Kerosene oil. The list is available on your book simultaneously. Then most important thing, what is the total internal reflection of the light? Can you give a definition? Shabash. What is TIR?
Anyone?
What is TIR?
Does anybody know what type is?
इससे तो रिवोल्यूशन आया है पूरी दुनिया में, आपको पता होना चाहिए।
Laser कहाँ
पता है?
You're looking for laser, I believe. Laser
Yes,
is
yes,
yes.
TIR is defined as a phenomena when a ray of light travels from denser medium to the rarer medium. If the angle of incidence is greater than the critical angle, then the incident ray comes back into the denser medium. You can see here, this is the ray first, isn't so? This is ray second. This ray has refracted. This ray goes along the interface. There the angle is 90 degree. Whenever the refracted angle is 90 degree, that time the incident angle is called critical angle. However, when it passes that, when the angle of this incidence increases the critical angle, then the ray of light comes back into the denser medium. You can see here in this laser tank that very thing, that beautiful pattern. You see here. नजर आ रहा है कुछ?
Yes, sir.
What you are observing? नहीं, are you finding that in a zigzag path?
Yes, sir.
कैमरा पे आ रहा है ये?
Yes, sir.
ये
You
जरा
let them
देखें।
have an opportunity to zoom at it.
You see, this is the incident यहाँ से आ गई, ठीक है? यहाँ पे फिर वापस आ गई, ठीक है? Zigzag. थोड़ा मैं इसमें वो ये जरा वो दिया।
अब
Please,
आप खुद भी जा सकते हैं इसमें
नहीं,
कोई-
इसमें थोड़े सर।
This one.
Yes. Okay.
Dettol.
हाँ, because this acts as a scatterer.
Yes.
ठीक है? Scatterer act करता है यहाँ पे। आप देखते हैं
थोड़ा मुख्तसर
यहाँ थोड़ा
से ही अगर
हाँ
आप इसको एक्सप्लेन करें तो बेहतर होगा।
ठीक है। यहाँ पे क्या है इस वक्त की लाइट की वजह से जो आपको यहाँ पर ग्लेयरिंग ज़्यादा होती है और यू नॉट इन अ पोजीशन टू सी द जिस इन क्लियर वे। जरा देखते हैं यहाँ से, अब आ गया?
Yes, sir.
ठीक है, जूम हो गया।
Yes, sir.
यानी कि दिस रे ऑफ लाइट कम्स बैक इनटू द डेंसर मीडियम। ये यहाँ पे रिफ्रैक्ट नहीं हो रही है, इट इज नॉट रिफ्रैक्टेड। ठीक है, आई कैन शो यू वन ऑफ द एप्लीकेशन ऑफ दिस, दैट इज द व्हाट यू आर हैविंग दोस ऑप्टिकल फाइबर्स ऑन दिस। ठीक है, टेस्ट ट्यूब। वहाँ पे क्या होता है, देयर इज दैट इज आल्सो एप्लीकेशन ऑफ द दिस TIR। जरा देखते हैं यहाँ पे। ये देखिए, zigzag आती है ना पावर।
Yes, sir. Yes, sir.
Isn't it so?
Yes, sir.
You can see here, it goes here and then comes here, then goes like
Comes
it works like a that what you call optical fiber. With this, I would like to conclude here, isn't so? Thank you very much.
Thank you so much.
Can I add
Thank you.
some points at the last moment?
जी बस एक मिनट आप वेट कीजिए सर। थैंक्स अ लॉट फॉर दैट ग्लोरियस लेक्चर। आप आके यू टेक अ ब्रेथ एंड बिकॉज वी आर हेडिंग टुवर्ड्स दैट section of the program where we interact with our dear viewers on the numbers 2481813, 2481832 is the other number, and do not forget to prefix 0194 before the number. We'll take the calls, but before that a short break. जी मलिक अल्ताफ साहब जुड़ चुके हैं हमारे साथ वेरीनाग से, काफी दूर से जुड़े हुए हैं हमारे साथ। अस्सलाम वालेकुम सर। अस्सलाम वालेकुम सर, खैर मकदम आपका प्रोग्राम में। सर अपने टेलीविजन सेट का वॉल्यूम आप कम कर दीजिए।
अस्सलाम वालेकुम
वरहमतुल्लाहि वबरकातुहू। अपना सवाल पूछिए सर।
जी मैं मलिक अल्ताफ वेरीनाग अनंतनाग से अर्ज कर रहा हूँ।
जी
मेरा सवाल है, जब हम एलिमेंट्री लेवल पर इस लाइट के कंसेप्ट को इंट्रोड्यूस करेंगे तो इंट्रोड्यूस करते वक्त हम ओपनिंग पार्ट हमारा क्या रहेगा और हमें किन टीचिंग लर्निंग मटेरियल का सहारा लेना होगा, क्योंकि लेवल एलिमेंट्री लेवल है और वहां पर भी ये मतलब लाइट का कंसेप्ट बच्चों को देना है। बच्चे बहुत छोटे हैं, तो क्या हम इन्हीं टीचिंग लर्निंग मटेरियल का सहारा लेंगे जब हम पढ़ाएंगे बच्चों को इस लाइट का कंसेप्ट?
काफी रेलेवेंट क्वेश्चन आपने पूछा। नज़ीर अहमद तांतरे सर ने क्वेश्चन सुना है, ये आपके क्वेश्चन का जवाब देंगे।
ओके
एलिमेंट्री लेवल पे सर कैसे पढ़ाना चाहिए, कैसे इंट्रोड्यूस करना चाहिए इस टॉपिक को?
एलिमेंट्री लेवल पर तो पहले ये बताना होगा कि what light is. So the basic answer to the light is that it is something which gives us the sense of vision. Something enters into our eyes and it gives us the sense of vision. We feel that we have seen something. So basically something enters into our eyes, and after entering our eyes, it goes to the optic nerve to the brain, and the brain, it is actually the brain which sees, not the eyes. Eyes are the instrument. So the first thing is that something enters. So what should enter our eyes so that we see something? Here is the positive point. Either it should be a particle or a wave, because there is no third entity available in the universe. Either it should be a particle or a wave. So we judge it as a particle, or we can judge it as a wave. And finally what we do is that we understand the properties of light. So light is not something that you see through and you can visualize what it is. So therefore we have to understand its properties. So what we do in the laboratory, we understand all the properties of light. On the basis of that, we can see whether it's a particle or a wave. Okay. And those properties, they reveal that it should be a particle, and those properties also reveal that it should be a wave. So we can start with the students so that students can understand the basic elementary things about light.
Yes.
Although it's a very complex phenomena, when we go ahead, finally the light is an electromagnetic wave and a photon.
Shukriya, and I would appreciate if the answers would be a little brief, because we have so many callers on the line. And Zohar Ahmed called us during the program from Patan, and he wanted to know the difference between the concave and the convex lens. I think he's got the answer. Sir has explained it very beautifully and very lucidly. And this email that we received during the week came from Ghulam Hassan Rishi. He's saying that Doordarshan Kendra Srinagar is doing a great job. My question is to Nazir Ahmed Tantre sir, is that why velocity of light, he says, is different in vacuum and a medium? It can be any medium. What relation exists between various velocities?
That's right. That's a very good question. You see, first of all, what is the velocity of light in vacuum? The velocity of light in vacuum is the highest possible.
Yes, sir.
No particle, no object ever can achieve the velocity of light. Right. If an object or a particle or anything of that sort exceeds the velocity of light, that will be a disaster for the theory of relativity. So let me be brief in my answer. Velocity of light is given by the electrical and magnetic properties of the materials. So the electrical and magnetic property of the vacuum is mu0, epsilon 0. These are the magnetic properties. And Maxwell proved that the velocity of light in vacuum is 1 divided by root of mu0 epsilon 0, and he calculated the value as 3 into 10 raised to power 8 meters per second. When light goes into the medium, it is the medium properties which are responsible now. So the velocity of light will be 1 by root of their electrical and magnetic properties, and their electrical and magnetic properties adjust the velocity of light to be lesser. So whenever light goes from one medium to another medium, the velocity decreases. It is because that it depends upon the electrical and magnetic properties of the medium.
Well, thanks a lot for that beautiful answer. We have Ishfaq Ali from Chadura. Assalamu alaikum sir. Ishfaq Ali from Chadura. Assalamu alaikum sir. Khair maqdam aapka program mein.
Hello.
Hello. Assalamu alaikum sir.
सलाम सर.
जी अपना सवाल पूछिए इशफाक साहब.
सर पहले तांत्रे सर को मैं सलाम करना चाहता हूँ. हेलो.
वालेकुम सलाम.
सर मैंने आपके पास पढ़ा है फिजिक्स टीडीसी एंट्रेंस में सर.
क्या बात है, क्या बात है. थैंक्स अ लॉट सर. रिस्पेक्ट. जी
सर आज आपको देख खुशी होगी सर.
जी हमें इस बात से खुशी हुई कि आपने अपने सर को इतना रिस्पेक्ट दिया आज इस प्रोग्राम में. अपना सवाल पूछिए सर.
सर मेरा क्वेश्चन है सबसे पहले तांत्रे सर से यही कि मैं इससे मिलना चाहता हूँ.
ये तो आपकी दिली चाहत है। सवाल है कोई आपका?
सर दूसरा क्वेश्चन है कि जो ये तैयार है ना
जी,
उसको ये थोड़ा बहुत बाजार से वहाँ पे।
जी जी जी, बिल्कुल बिल्कुल, आपका सवाल बिल्कुल बजा है। थैंक्स अ लॉट फॉर कॉलिंग। इससे पहले कि आप जवाब दें,
खुद तांत्रे सर से मैं सुनना चाहता हूँ सर।
डेफिनेटली तांत्रे सर ही जवाब देंगे, मैं तो एक्सपर्ट नहीं हूँ।
क्वेश्चन
टोटल इंटरनल रिफ्लेक्शन के बारे में पूछना चाहते हैं, लेकिन उसी से सटा हुआ एक मेल हमें इरम शफी से मौसूल हुआ है, जो कि चाडोरा में रहती है। एंड शी राइट्स, अगेन शी इज योर स्टूडेंट, इट्स एन ऑनर फॉर मी टू वॉच माय फेवरेट टीचर नजीर अहमद तांत्रे ऑन टीवी। माय ओनली ऑब्जर्वेशन इज दैट I would want him to elaborate on the uses of total internal reflection. दोनों का एक ही सवाल।
Okay, but it will take a little more time. You have to give me 2 minutes.
Yes, please, please.
Total internal reflection is based on the refraction rule. You know, when the light goes from one medium to another medium, it bends towards the normal or away from the normal. When ray of light goes from denser into rarer medium, it bends away from the normal. That means the angle of refraction is more than the angle of incidence. But if you adjust the angle of incidence in such a way that the angle of refraction increases, and finally it goes along the surface the way sir has explained, it will go along the surface. So from that point onwards, if you increase the angle of incidence, the ray of light will come back into the same medium. It is very interesting. Both the media are transparent, and still the light is coming back to the same medium.
Absolutely.
But here one point is to be explained, that when it reflects back, it is the reflection rule which is followed. The refraction rule is not followed, because now the ray will be reflected. So it will not be like this and going up and then like this. It will be going back into the same medium.
Absolutely.
So total internal reflection is based on the rule of, you see, the rule is for this what you call as Snell's law. Snell's law is mu1 sin I is equal to mu2 sin I, or you may put it in the ratios also. That is an equally good formula, but it is better to mu1 sin I is equal to mu2 sin R. It's a good way of doing it. So if you increase I, you will increase R, because mu1 and mu2 are constant. So a time comes when R becomes 90, and from there onwards it gets back into the same medium. Number one. Number second, there are so many applications, the way sir has explained, that optical fibers.
Yes, sir.
When the light gets trapped. And then there's one more thing, that's sparkling of light inside the diamond.
Absolutely sir, बहुत सारी फोन कॉल्स हमें है लाइन पे अभी, लेकिन उससे पहले जी MK भट्ट जी जुड़ चुके हैं हमारे साथ दिल्ली से, हमारे रेगुलर कॉलर है सर, रेगुलर व्यूअर हमारे प्रोग्राम के। गुड मॉर्निंग भट्ट जी। भट्ट साहब खैर मकदम आपका प्रोग्राम में। लगता है कॉल ड्रॉप हो चुकी है, लेकिन सर जुनैद भट्ट साहब ने अभी हमें मेल करा है, एक इंटरेस्टिंग सा मेल है। ये रहते हैं लाल बाजार सिद्दीकल में रहते हैं। कहते हैं कि मैं एक एंट्रेंस स्टूडेंट हूँ, कुछ हफ्ता पहले यहाँ से एक प्रोग्राम चला था जिसमें कि फिजिक्स के एक्सपर्ट सर थे, शायद आप नहीं थे, तो उन्होंने ये कहा था कि अगर मैकेनिक्स पोर्शन में आप गुड नहीं है, आपको लगता है आप इसमें पार नहीं पाएंगे, तो उसको ऑल टुगेदर छोड़ दीजिए। तो ये कह रहे हैं कि मुझे नहीं लगता इनके हिसाब से कि मैकेनिक्स पोर्शन को ऑल टुगेदर छोड़ के हम किसी कॉम्पिटिटिव एग्जाम में पास हो सकते हैं। तो इसके बारे में आपकी राय जानना चाहते हैं।
The boy is right. You see, you can't. Mechanics is the backbone of physics. You see, most of the things are explained through mechanics, mechanical laws, and mechanical laws are based on Newton's rules. So you can't avoid Newton's rules. So Newton's rule is 90% of physics that we do is because of by Newton's rules.
Absolutely.
So I will not recommend that. I will recommend that he should concentrate on mechanics.
उसमें मार्क्स की क्या वेटेज है उसके बारे में जी? Mechanics portion.
Mechanics portion. If he does mechanics very thoroughly, I think he should be able to solve at least 50% of questions.
Absolutely, that's wonderful. That's just so fascinating. And अभी सुहेल अहमद साहब जुड़ चुके हैं शुपैन से हमारे साथ। अस्सलाम वालेकुम सर। सुहेल साहब खैर मकदम आपका प्रोग्राम में, अपना सवाल पूछिए।
जी सर, मेरा सवाल एक्सपर्ट से ये है कि मतलब जब हम सवाल मेरा ये है एक्सपर्ट से कि जब हम गवर्नमेंट स्कूल में साइंस पढ़ाते हैं
जी,
तो साइंस पढ़ाते समय स्पेशली सेकेंडरी लेवल पे जब हम साइंस पढ़ाते हैं तो लाइट पढ़ाने के लिए हमारे पास जो लाट होता है, मोस्ट ऑफ द स्टूडेंट्स उस लाट में होते हैं कि उन्होंने मिनिमम लेवल ऑफ लर्निंग क्लियर नहीं की है। मतलब अगर हम देखेंगे क्लासरूम में तो 70% स्टूडेंट्स ऑल दो स्टूडेंट्स होते हैं कि those who don't have cleared their minimum levels of learning.
जी।
So how can I teach them the concept of light?
नहीं, आपका सवाल बिल्कुल बचा है, लेकिन जो इंस्ट्रूमेंट्स इन्होंने यूज किए बिल्कुल लो कॉस्ट नो कॉस्ट एक्टिविटीज है, और बिल्कुल बिगिनर लेवल पे भी अगर आप मान लीजिए ह्यूमैनिटीज का स्टूडेंट को भी इस तरीके से पढ़ा जाए तो मुझे नहीं लगता उतनी मुश्किल होनी चाहिए समझने में। सर आप क्या कहते हैं, जो बेसिक लेवल पे गवर्नमेंट स्कूल्स में?
एलिमेंट्री लेवल पर स्टूडेंट्स को सिर्फ यही कहा जा सकता है ज्योमेट्रिकल ऑप्टिक्स।
जी,
ज्योमेट्रिकल ऑप्टिक्स में बेसिक रूल यही है कि द लाइट शुड बी कंसिडर्ड एज ए पार्टिकल मूविंग इन ए स्ट्रेट लाइन।
जी,
So if he rectilinear propagation, don't go into the electromagnetic wave theories, the Huygens wave theory. Those are the things of higher level. And you go in 11th and 12th and BSc first year, second year, or third year. You go to the different aspects of light. You see, polarization is there, diffraction is there, interference there, but those are the phenomena which cannot be explained to the 10th class student. Because for that you need a good level of mathematics. So what I recommend to the teachers, those who teach at 10th level, school level, they should concentrate on geometrical optics. And they should not go beyond that. Just tell them it is a particle moving in a straight line in the same medium, gets reflected as the billiard ball gets reflected from the wall. But that also follows the same rule, I is equal to R. And tell them that billiard ball or something goes into the medium water and it goes inside, it bends towards the normal. It's very simple that way.
Absolutely. आदिल अहमद साहब जुड़ चुके हैं मुजगुण से हमारे साथ. अस्सलाम वालेकुम सर. जी.
Sir, one more thing I just want to ask, that is this thing कि
जी आदिल साहब जुड़ चुके हैं शायद हमारे साथ मुजगुण से. लगता है कॉल ड्रॉप होगी. सर सबसे पहला सवाल मेरा बेसिक से ही मैं स्टार्ट करूंगा बिकॉज आज आप आए हैं तो फिर दोबारा आपका बाय वैसे हम चाहेंगे आपको बार बार बुलाना, मैं शायद यहाँ पे ना हूँ. तो मैं आपसे ये सवाल पूछना चाहूँगा. देखिए फिजिक्स जहाँ तक मैं अंडरस्टैंड करता हूँ चांद तारों की बातें होती है, सयारों की बातें होती है, ऐसा कॉन्सेप्ट फिजिक्स यहाँ पे देता है. बट हम फिजिक्स की टीचिंग को क्लास में क्यों महदूद करके रख देते हैं? एक ब्लैक बोर्ड, काले रंग का चाक, व्हाइट कलर का ब्लैक बोर्ड, ठीक है. तो ये क्यों है? हम क्यों ऐसे आलात और ऐसे इंस्ट्रूमेंट्स क्लासरूम में इंट्रोड्यूस नहीं करते राइट फ्रॉम द गवर्नमेंट स्कूल लेवल?
I think there should be no reason why can't we do it? Whatever is possible in the school at the school level, the school teachers are doing that. I don't say there is a problem of infrastructure, there is a problem of laboratories. Those problems are there. I can't say that we can do all these things in what Sir has done here. It can be done in all schools, but there are some schools which do these things. Certainly, in government schools, there are some schools where these activities are being performed.
तो आदिल अहमद साहब जुड़ चुके हैं हमारे साथ मुजगुण से. अस्सलाम वालेकुम सर. आदिल साहब खैर मकदम आपका प्रोग्राम में, अपना सवाल पूछिए.
जी मेरा चुनाव आदिल अहमद मलिक मुजगुण श्रीनगर पे
जी.
मेन सवाल है यथ कन मे मतलब सब्जेक्टस मुतलिक सवाल कि अलबत्ता एजुकेशनल सिस्टमस मुतलिक मे सवाल
जी
कि ये एलिमेंट्री लेवल या हायर लेवल मज परनावान मिसाल के तौर पर परान इंग्लिश लैंग्वेज.
अच्छा.
मतलब चैप्टर 10 चैप्टर 20 मगर मतलब बेसिक फॉल्ट कि एलिमेंट्री लेवल पे मतलब स्पीकिंग कोर्स सेपरेट मतलब ग्रामर एक्सपर्ट मतलब ग्रामर.
चलिए मुझे लगता है आपका जो सजेशन है वो हम तक पहुंच चुका है. तुहंद जुज सजेशन रोज वो तस्निश इंशाल्लाह इस बात ना ये अला हुकामन ताम. शुक्रिया कॉल करने के तुहंद. एंड कुछ ईमेल्स हैं हमारे पास. अयाज अहमद कुरैशी लिखते हैं HMT श्रीनगर से. इट्स रियली अ ट्रीट टू वॉच दीज एक्सपर्ट्स एंड टीचर्स ऑन दूरदर्शन केंद्र श्रीनगर. द स्टूडेंट्स विल डेफिनेटली गेट बेनिफिटेड. ओनली रिक्वेस्ट इज टू काइंडली हैव वन मोर सच प्रोग्राम इन अ वीक. वेल थैंक्स अ लॉट. वी हैव टेकन योर सजेशन एंड वी लुक टू इट दैट this suggestion is taken up by the higher authorities. Then we have Sayyid Hazik from Parimpura, Srinagar. He writes that a wonderful program. Congratulations to Doordarshan Kendra, Srinagar. My request would be to have a lecture on a modern pedagogy. I hope to pronounce it correctly. And modern teaching approach. Yes, it is the need of the hour. Well, thanks a lot for this wonderful email. We have Amir Sohail from Pulwama. Assalamu alaikum, sir. Assalamu alaikum, Amir साहब. खैर मकदम आपका प्रोग्राम में. आमिर साहब खैर मकदम आपका प्रोग्राम में, अपना सवाल पूछिए. लगता है कॉल ड्रॉप हो गई सर.
हेलो सर, आई लॉस्ट द कॉल.
No, you are very much here in the program. Please ask your question. Amir? I think we lost Amir on the call. सर ये क्वेश्चन मेरा था कि 11वीं 12वीं में जब हम फिजिक्स पढ़ते हैं तो 11वीं 12वीं में क्या होता है कि जब स्कूल्स में हम जाते हैं तो बच्चे कहते हैं कि जी आमिर साहब एक सेकंड सर. आमिर साहब आप हमें सुन पा रहे हैं क्या?
जी 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 सर मैं सुन रहा हूँ.
जी अपना सवाल पूछिए.
सर मेरा डायरेक्ट क्वेश्चन है खुर्शीद सर से. खुर्शीद सर से मेरी डायरेक्ट रिक्वेस्ट है.
हाँ
कि इनका वे ऑफ टीचिंग प्रैक्टिकल अप्रोच बहुत अच्छा है. आई लाइक इट. मैं खुद पढ़ा रहा हूँ
जी.
तो क्या मैं पर्सनली इनसे मिल सकता हूँ?
व्हाई नॉट. यस जरूर मिल सकते हैं
जी. डेफिनेटली आप इनसे पर्सनली मिल सकते हैं. कॉन्टैक्ट नंबर वगैरह हम फोन प्रोग्राम के बाद आपको बताएंगे, उसमें कोई दिक्कत नहीं है. सर मेरा क्वेश्चन मैं आपसे ये अर्ज कर रहा था. शुक्रिया कॉल करने के लिए. बाय द वे मैं ये अर्ज कर रहा था आपसे कि जब हम स्कूल में 11th 12th की बात में कर रहा था तो वहां पे उनका थ्रस्ट जो होता है कि बेसिक्स को क्लियर कीजिए, ठीक है, और जब बेसिक्स को क्लियर करने की बात होती है उसके बाद उन्हें एंट्रेंस एग्जाम भी फेस करना होता है, तो ऑल ऑफ अ सडन अ लॉट ऑफ प्रेशर इज ऑन द स्टूडेंट्स कि 6 महीने में आपने सारे न्यूमेरिकल्स करने हैं, बिकॉज आफ्टर ऑल एंट्रेंस एग्जामिनेशन इज अ गेम ऑफ इट्स अ गेम ऑफ न्यूमेरिकल्स विज़ावी फिजिक्स।
right.
तो आपको नहीं लगता 11वीं से ही न्यूमेरिकल्स थोड़े थोड़े ऐड करने चाहिए बेसिक्स को क्लियर करने के
मुझे
साथ?
लगता है कि those who want to clear these competitive exams,
जी
they should start. Somebody wants to
Right.
become a doctor, somebody wants to become an engineer, somebody wants to crack IIT. They should start their preparation early from 9th class,
हाँ, क्या बात
so that they have a good number of years to prepare for the exam.
है जी।
So it is not that in the 12th class and you start now preparing for. You can't compete with those students who are preparing outside in coaching centers.
जी
You can only compete with them
जी
when you have already planned, and the plan must be from 9th class.
जी जी। So the earlier you plan, the better are your chances of passing the entrance
better are the
examination.
chances.
We have MK Bhatt reconnected to us. Adabar sir, good morning.
Good morning. Good morning. I lost my call, previous call. I am once again on the show.
It was our loss, sir. It was our loss.
Yes, I lost my call. I am once again to the show. I have heard the concerned teacher. I have heard him before as well. You have invited him. He is giving good lecture. I think he is on the spot, and expert is also on the spot.
Ji.
I am little on this subject, but I want to speak both of the teachers, the experts. I expect the experts. The expectations are going day by day high. There is a question: electromagnetic rays are there in the rays when you are reflection into concave and convex lenses. I want to know, for my knowledge, I am not too much versatile in this subject,
Ji.
but I want to speak that when there is a black object and a transparent object, when the rays of light nowadays with the heat of the waves, they fall on this. I want to know, for my knowledge, why the absorption of black objects is much more in them, in absorption of heat. But on the transparent, is it a reflection, or they are making these rays, heat waves away
Ji.
from that transparent object?
Ji sir, I think
want to know
we
myself.
have got your question. Is there any other question that you would like to ask, sir? Well, I think we have got his question. When light falls on black and white transparent object, what happens? Yes.
The point is, light is an electromagnetic wave.
Ji.
You see, it is a small window of the whole electromagnetic spectrum,
Ji.
the way sir has explained.
Mhm.
All the electromagnetic waves from gamma rays down to the long waves,
Ji.
it is a whole electromagnetic spectrum. And light is a small window of this electromagnetic spectrum from 4,000 angstroms to 7,000 angstroms.
क्या बात है?
Right? So when radiations fall on a black object, that's called black. Why? Because it absorbs all the radiations. That's why it seems to be black. Anything which is being reflected, that gives the color. Something is red, it reflects red color.
Ji.
So reflection gives the color. So when radiations fall on a black object, it absorbs all the radiations. So its temperature rises quickly. That was his question. Why should the temperature of a black object be higher? Because it absorbs all the radiations.
Right.
That is why it's black. Black means it does not reflect any of the frequencies.
Right.
The moment it reflects any frequency, that will give it the color.
तो बजाते खुद लाइट का इसमें कोई इंटरफेरेंस नहीं है. It depends on the color.
Absorbed radiations.
Yes, absolutely. We have Tajammul from Pampur, Saffron Town, Pampur. अस्सलाम वालेकुम तजम्मुल साहब, खैर मकदम आपका प्रोग्राम में.
अस्सलाम वालेकुम सर.
वालेकुम अस्सलाम.
जी थैंक यू सर. खुर्शीद साहब से मेरा क्वेश्चन है, हाउ टू एक्सप्लेन रिफ्लेक्शन.
हाउ टू एक्सप्लेन रिफ्लेक्शन. मेरे ख्याल में इस पे बात हो चुकी है, फिर भी कुछ तो मुख्तसर अगर आप कुछ कहना चाहिए. जी शुक्रिया कॉल करने के लिए. जी
रिफ्लेक्शन पे हमने बात की, आपको कह दिया कि इट इज द बाउंसिंग बैक ऑफ द लाइट इन द सेम मीडियम. सो you can have reflection on the atomic level also, you can have reflection on this in terms of the geometrical optics also, but here we used to teach you just on the basis of the geometrical optics, not taking you people to the making you apply to the electromagnetic waves, where the things for you people are very difficult. So these low-cost materials are just made for that very thing, that you can get the things with ease. As I have shown you the reflection with the help of this very Bacchus, here is actually a mirror which reflects the light, and there was a curved two mirrors, one this and second this.
जी do we have a caller on line? लाइन ड्रॉप हो गई है सर. एक लास्ट सा क्वेश्चन मुख्तसर सा, जो टीचर्स आपको देख रहे हैं, जो स्टूडेंट्स को तो मैसेज ये देते रहते हैं, जो स्टूडेंट्स स्कूल्स में कॉलेज में पढ़ाते हैं, उनके लिए आपका एक मैसेज सर.
For what? For
How to teach physics in a much better way.
for teachers.
Yes, sir. Because given your experience of teaching physics from last 20 to 25 years, sir, a small brief message at the end to the teachers.
My message to the teachers is that try to explain physics, basic laws of physics, without doing much number of problems or objectives. Try to concentrate on the basic rules, because physics is something like, you see, it's not physics is once you know the rule, you can apply that rule to many other places. It is better to do a single problem rather than to do so many problems. A single problem will teach you how to apply the rule. If you are learning a problem, you pick up the rule in that problem and apply that rule to many other places where you can do physics. My suggestion is that you concentrate on the basic laws of physics. Teach them to the students in the very nice way, and then the problems and objective students can tackle themselves, I think.
Well, thanks a lot, sir, for that glorious answer, and thanks a lot, Khurshid Ahmed Rathir साहब, for teaching physics. As you always do, आपका एक अपना मुनफरद अंदाज है physics पढ़ाने का, और आप इसी पे बने रहिए, because it's quite unique and it's quite easy to understand for the students. And again, Nazir Ahmed Tantre sir, thanks a lot for bestowing us with all the experience that you have vis-a-vis teaching physics. And thanks a lot for the students. इनका welcome करना हम सुबह भूल गए थे, but thanks a lot. This program is successful only and only because of you. Repeat timing सुबह बताएगी.
या नाजरीन, जाते जाते आपको मैं याद दिला दूं कि आप इस प्रोग्राम के रिपीट टेलीकास्ट मंगलवार को शाम 7:30 बजे और जुमेरात को सुबह 9:10 पे भी देख सकते हैं. एंड डू वॉच इट अगेन एंड गेट अपडेटेड योरसेल्फ.
एब्सोल्युटली. एंड इसी दुआ के साथ कि नाजरीन जो भी करे, अल्लाह उनको कामयाबी और कामरानी से हमकनार करे. दीजिए अपने मेजबान जमशेद रसूल और हुमैरा शफी को आज के प्रोग्राम से इजाजत. अल्लाह हाफिज़.